of f products the limit of g. And 7, of course, you can find the limit of the numerator in denominator. But we should remember right. This equality succeeds 7. If only we provided right, this is not 0. If this is 0, we will have division by 0. So this is wrong, right? Meaningless. So 7 succeed, provided limit. This limit is not 0. If it's 0, you can write 0 over 0 in your paper or in your test paper. This is wrong. Okay, 0 score. Maybe I will give you 0 score. And number 8, this means fx times fx, we have n, fx nth time. Nth time, the times together. We can write is equal to first calculate limit of fx. In this, we have the nth power. Here, the nth third provided, the nth third provided. This is greater than 0. We n is even number. For example, the square root, the first root. Okay. Theorem A remains true for both left and right hand limits. There's one-sided limit. They are right. We write this x approaches C from right, or from left. They are all succeed. And we will have the applications of the man limit theorem. In the next examples, the circled numbers refer to the numbered states from theorem A. Each quality is justified by the indicated statement. For this one, is find the limit x approaches 4, 3x squared minus 2x. This is, we have the difference of two functions, right? So we can first write the limit of the first function and then the limit of the second function in their difference minus. And then 3, we take 3 in the front, we take 2 in the front, right? And here this is x squared, limit x approaches 4, x squared. We can write the limit x approaches 4, x, then square. Okay. First the limit, then square. Okay, this is the first square, then limit. We can change the order. So this is equal to 4 square. Okay, this is 4. So we have this 40. Example 2, any questions? Example 2. Okay, I think example 2 is easy, right? And example 3. Example 3 is also very easy. This is a quotient. We can find use theorem A. We can first find this limit 4 over. We can write like this. And we know here the denominator, this is called the denominator is, this is a 4, right? It's not 0. So we can write like this. But if it's 0, maybe we can think of another method to solve it. Here, this one we can write, we can first limit this square root. And then you can find this is equal to, here this is 4 square plus 9, right? So just 5 over 4. Example 3. What's wrong? Oh, what? What numbers? We can first write x is 4. Of course, if you are to circle numbers. Okay, no, is you can use, yes, you can use 4 from beginning, and in our solution number. Okay, this is just to remind you. This is because maybe we first touch this part, so he has write clearly, and yes, just over equal sign. Yes, right. This is just to let you know we use which equality. This 7 equality, 9 and 2 equality, 4 equality. And in your homework and your examination, you just write equal, equal, equal. Okay? Okay. And then we have the polynomial function. I hope you remember the polynomial function f has the form. This is an xn, an minus 1, xn minus 1 plus a1x plus a0. And the rational function, I hope you remember, is a polynomial. Rational function is a quotient, is a quantity of two polynomial functions. Theorem B, we have substitution theorem. This means if f is a polynomial function or a rational function, then substitution. This means we take limit is equal to just substitute x by c. Substitute x by c is fc. So this is called substitution theorem. But we should remember, if we have condition, if f is polynomial function or rational function, then we have the substitution theorem. And provided fc is defined. Okay. In the case of rational function, this means that the value of the denominator at c is not 0. Always remember that. Avoid dividing by 0. Avoid the negative. Avoid the avoid the even root of negative number. So note that theorem B allows us to find the limits for polynomial and rational functions by simply substituting c for x throughout. Provided the denominator of the rational function is not 0 at c. So this means, for example, for this one, we want to calculate the x approaching 1, the x cubed plus 8x plus 6. We know this is cube, rational function. And by substitution theorem, we just substituting c is 1 for x. Substituting 1 for x. So 1 cube plus 2 times 1 plus 6. So we can find this is 15. Right. So by substitution theorem, it's very simple. Provided fc, this means fc, this one is defined. Okay, is defined. But we have remark here. When we apply theorem B is substitution theorem. We say we evaluate the limit. We evaluate the limit by substitution, right? And not all limits can be evaluated by substitution. We consider can we do it by substitution? If we substitute x for 1, if we substitute x for 1, this is 0 over 0. This is not defined, right? So for this one, although this is a rational function, that's not defined. So the substitution theorem does not apply here because the denominator is 0 when x is 1, but the limit does exist. Right, we can factor the numerator. We will get the result. Maybe we can. It's wrong. Factor. Yes, this is wrong. Factor. This is x. X approaches 1. Factor right to x. Yes, right. And here we know x is near. Well, here x is near 1. But x is not 1. Right? So if x is near 1, x is not 1. Please tell me this one is equal to 1. So we can write is equal to limit x approaches 1, x plus 1, right? Because this is 1. And then we can use substitution theorem, right? Substitute 1 for x for 1. So the limit does exist. Yeah, this is the limit too. What? This one is this simple. Okay. And for example 5, this one is also simple. This is a rational function. And first we should make sure the denominator here is not 0, right? We find of course it's not 0. We just use substitution theorem, get the result is minus 11 over 2. Only for this part, we should careful. We should be careful. Okay, next. Next, this is in many cases, theorem B cannot be applied because substitution of C causes the denominator to be 0. In cases like this, it sometimes happens that the function can be simplified. For example, by factoring, for example, we can write here. If this is x, we talk about x approaches 2. We find this is 0 over 0, 4, right? And we can, by factoring, what's the denominator? This is the denominator. This part is denominator. This part is numerator. 分子分母. You learn this Chinese word? This is denominator, this numerator. You can use the translator. Okay, by factoring, cancel, x plus 5 or x minus 3. We have to be careful with this last step. The fraction is equal to the one on the left side of the equal sign only if x is not equal to 2. If x is equal to 2, the left side is undefined. This is the left. And because the denominator is 0, whereas the right side is equal to 7 over 5. This brings up the question about whether the limits are equal. Okay, the answer is contained in the following theorem. We have theorem C. This if f(x) and gx for all x in the open interval containing the number c, except possibly at the number c. And itself, if the limit as x approaches c of gx exists, then the limit as x approaches c of f(x) exists, and yes, they are equal. So this, yeah, right, they are equal, right? Okay. And for example 8. Oh, example 8 is just this one. We might take. They are equal. X approaches 2. X is not 2, so this is 1. So it's equal to this one. Calculate this one, just use substitution theorem. We have is 7 over 5. Exam 8 and the questions for exam 8. No? Okay, we continue. Okay, we will learn later the squeeze theorem. Maybe we should learn this last time because this theorem I just introduced later about this squeeze theorem. You have likely heard someone say I was caught between a rock and a hard place. And this what happened to G in the following theorem. You know, here, what's this G? Here, this is the graph, this is the graph, this is the curve, this curve, the lower curve. Okay, this curve is F. And the upper one is H. And the middle part is G. And it's G. So we say G was caught between a rock and a hard place. Right? Between there. So this is the squeeze theorem. This means we have three functions, F, G, and H. Satisfying. Can't understand. It's just there's nothing about our knowledge. Okay, it's just be like that. You can translate this word. This means you are in a hard place in between two. This means G is between these two curves, right? So we can see he's in a hard place, right? So this means. Okay, this we have theorem D. This is called a squeeze theorem. We have three functions. Three functions. We have the relationship. It's f(x) is less than or equal to gx. Gx is less than or equal to hx. Oh, just like this, right? G is between there. For x near C, this means x equal to C. X near C, except possibly FC. No four functions, just the three functions. Okay, just the three functions. We have the squeeze theorem. Except possibly at C, x near C, here x near C. Okay, we have what? We have the limit x near C. We find f(x) approaches here, approaches a number L. And we write like this. X approaches C. We write here. X near C. We have f(x) is near number L. And G and hx is near the same number L. Like this. This is C. We can find f near L, right? L is here. And H is also near L, right? So, and because G is between them, you can guess Gx is near which number? It's between them. And they have this relationship. You can guess Gx is near which number? From this curve. It's also near L. Right? Gx is also near L. This is called a squeeze theorem. Because, you see, F is near L, H is near L, and G is between them. So this means proceed G near L, right? We can think of like this, almost. So from this, maybe we can understand it. What's the meaning of squeeze? Maybe you should use the translator. Squeeze. If I translate it for you, maybe I want to translate just for Chinese. Explain it for Chinese. This is 压缩. In English, just the squeeze. I don't know how to translate this word. It's just called squeeze. Maybe you can translate in your language. You can understand it, right? If you don't know this word, yeah. SQUEEZE. Right? Because if you don't understand Chinese, English word, you can translate it. Because I also don't know how to explain this word. It's just a squeeze. It's just about I don't know how to explain 压缩. Because in Chinese I know this meaning, but I don't know. Yes. This means here F is here like this. Maybe you can see. Okay, I said here, right? I said here. The squeeze be like this. H is upper. This is the function. H is upper. F is lower, and we have maybe this one, this G, and squeeze. X is near C. This means upper near air, lower near air. So purchase the middle part. G is near air. So this means squeeze theorem. Okay, what's the time? Maybe we have one break. Maybe we can. Okay, maybe we can end our class an hour, right? Yeah, right. So you can see the Lily sent the message from Lily. It's right. With comparison with two other functions, whose limits are known to easily compute. Right. It's right. Beautiful. Then yes, this is. And we will use squeeze theorem. Right. I explain it again. Yeah, I think Lily is a good student. Right. Thank you, Lily. I hope to see you, but you are not in China. It's a pity. Bye bye. Oh, no. Bye. Yeah, I think so. Because you just start late. We just in our class 5 weeks, right? It's not on the first week or third week, second week. It's 5 weeks. What?